Aloha! Welcome back to Math Camp. I'm Dane, and this is something I call the true history of Bayes' theorem with Sogrates and Amphibianes. You will play the part of Sogrates, and
Amphibianes plays the part of himself.
through painstaking research, I have traced the beginnings of Bayes' theorem to ancient Greece. I have discovered a lost manuscript about the greatest philosopher of all time. Though long since forgotten, at one time he was so great that people called him Sogrates. This manuscript describes a dialogue between Sogrates and one of his students, Amphibianes, who was always hopping all over him with questions. Throughout the following reconstructed dialogue, notice how Sogrates employs the Socratic method, by which the student is brought to knowledge through queries such as, "What's so great about that?" Remember, you will be playing the part of Sogrates, and I will help you with that, and Amphibianes will play the part of himself.
Oh, great Sogrates, I'm flippin' upset.
Why? Oh, why, Lily Hopper?
I was going to take Miss Piggy to the hop next week, but I just found out that I have swine flu. Soon I'll be green about the gills.
So how do you know that you have swine flu?
Hey, I'm not just another pretty face, you know. My buddy Elmo Stottle and I took a legitimate test. I tested positive, and he tested negative. I don't want Miss Piggy to wallow in self-pity, so I'm going to have him take her instead. Besides, he really loves to dance.
Yeah, Elmo Stottle can really cut a Persian rug.
I see. What test did you take?
One of those home tests that you can take on the privacy of your own pad. It was a pain because my sundial's a little slow.
What is the sensitivity rate?
Let me see. It says here, chiseled in the insert, that the sensitivity rate is 80%. What does that mean?
Well, that tells you the probability of a true positive, meaning if you have swine flu, the chance that you will actually test positive.
So, there's only an 80% chance that I have swine flu?
No, you also need to know the specificity. What does that say?
It says 60%. How does that help?
That's the probability of a true negative, meaning if you don't have swine flu, you will actually test negative.
Elmo Stottle tested negative, so there's a 40% chance that he actually has it?
No, you also need to know the present prevalence of swine flu, which is about 25%.
That counts too?
Count! Everything counts!
This is still Greek to me.
Of course, O Krokmeister, we are in Athens. The fact is that there's actually a 40% chance that you have swine flu.
Not 100%?
Not even close. And Elmo Stottle still has a 10% chance of having it.
Not 0%? How do you know that?
Bayes' theorem.
Bayes' theorem? Is that an antidote for swine flu made from bay leaves?
No, it's a way to understand the interrelationship between specificity, sensitivity, and prevalence, which will be investigated sometime in the future by Reverend Thomas Bayes.
Sounds like you have to be a catapult scientist to figure it out. How does it work in this case?
You tell me.
You mean that you're not going to spoon feed me like any good teacher would do? Okay, I'll try, but let's use the KISS principle. Keep it simple, Sogrates. Besides, the KISS principle makes me feel princely.
First of all, how many creatures live in Athens?
I'd estimate 100, since it's the biggest number that I can think of.
Excellent choice. Even if it's not precise, you can easily figure the rest out using the method of natural frequencies.
Good, because I know Miss Piggy is rooting for me. Since the prevalence of swine flu in Athens is 25%, that means 25 creatures have it and 75 don't.
In all likelihood, yes.
Now, which do I do next, the sensitivity or the specificity?
You tell me, oh fly breath.
You're really making me work here, aren't you? Well, with all this talk of bay leaves, makes me think of keeping track of this using two branches. On the right, those that don't have swine flu, and on the left, those that do. And I assume that they all have gotten tested.
An excellent approach to conditional probability.
Now, since the sensitivity rate, in other words, the percent of true positives, is 80%, and only those with swine flu yield true positives, 80% of 25 creatures will be outed. In other words, 4/5 of 25 creatures is 20. What about the other 5? They have swine flu and nobody knows.
Yes. And what about the rest?
Well, since the specificity... I got a person in my throat. In other words, the percent of true negatives is 60%, and only those without swine flu yield true negatives. 60% of 75 creatures it will be cleared. In other words, 3/5 of 75 creatures is 45. What about the other 30? They will think they have swine flu, but they don't.
Yes. What are the chances that you have swine flu knowing you tested positive?
Even a graduate of the Plato Academy can figure that out. Since 30 plus 20 creatures tested positive, and only 20 of them are true positives, that's 20 out of 50, or 40%. Oh, I see. That's how you figured I'd only had a 40% chance of really having swine flu.
And Elmo-Stottle?
Simple. He tested negative. Since 45 plus 5 creatures tested negative, and 5 of them actually have it, he has a 5 in 50 chance of having it. 10%, like you said. But this makes me a little bit jumpy.
How so, my little pollywog?
If 100 creatures take the swine flu test, 30 plus 20 equals 50, test positive, and 45 plus 5 equals 50, test negative. What the frog? I could go down to the agora and charge everyone a drachma, flip it, and tell them they have swine flu if it's heads, and not if it's tails, and be 50-50. I'd identify half the infected creatures correctly, half of 25 is 12.5, and half of the uninfected ones correctly, half of 75 is 37.5. So I identify half of the 100 correctly. 12.5 plus 37.5 equals 50. That's 50% accuracy. This test is only correct 65% of the time because the number of true positives is 20 and the number of true negatives is 45. My coin flip method is pretty darn close and a heck of a lot cheaper. How do you improve on that?
Develop a better test.
Stop pulling my leg. This test cost the taxpayers a lot of green. At the risk of sounding a tad political, I just say that I'm an anti-taxer. But I don't want to get bogged down discussing it right now, because it doesn't really matter anyway.
Why not, oh bug-eyed one?
I'm going to take Miss Piggy to the hop after all.
Why? Did Bayes' theorem help?
Not really. As much as I enjoyed our banter, I just remember that Miss Piggy grew up with a herd of swine out on the plains of Marathon.
What's so great about that?
Haven't you heard of herd immunity?
And that's the true story of Bayes' theorem. Honest.
But wait! There's more!
But first, the Happy Dance! A theorem by Bayes helps us to know conditional probabilities and how they grow. Just shake gray leaves, and you will find it'll be your chance to the happy